In this video, we'll give a formula for Newton's method. So remember how Newton's method works. We have a root that we want. We start with an arbitrarily selected number near the root. We call it x sub 0. We look at the function at that point. We follow the tangent line. We get down to x sub 1. We follow the tangent line at this point. We get to x sub 2. We follow the tangent line at this point. We get to x sub 3. And you see that these numbers, x sub 0, x sub 1, x sub 2, are getting very close to the root that we are looking for. If we have one of these numbers, how do we find the next in the sequence? This is x sub k. We want to follow the tangent line and find x sub k plus 1. Well, let's work it out. This is the point x sub k, comma f of x sub k. This tangent line is y equals f of x sub k plus f prime of x sub k times x minus x sub k. We are looking for this value, x equals x sub k plus 1. And at this value, y equals 0. So 0 equals f of x sub k plus f prime of x sub k times x sub k plus 1 minus f prime of x sub k times x sub k. Just to distribute this multiplication over this subtraction. Let me see. We want to know what x sub k plus 1 is. We'll add this to both sides. F prime of x sub k times x sub k equals f of x sub k plus f prime of x sub k times x sub k plus 1. Subtract this from both sides. We're running out of space, but minus f of x sub k plus f prime of x sub k times x sub k equals f prime of x sub k times x sub k plus 1. And now, as I am about out of space, let's divide both sides by this derivative. F prime of x sub k. When we divide this by f prime of x sub k, of course, these cancel. And then on the right, we are dividing by this as well. And these things cancel. So let's maybe write this a little more neatly on its own piece of paper. To apply Newton's method, we start with some guess. Then x sub 1 equals x sub 0 minus f of x sub 0 divided by f prime of x sub 0. Once you've defined x1, you can define x2 in terms of x1, and in general, x sub k plus 1 equals x sub k minus f of x sub k divided by f prime of x sub k. And Newton's method is a root finding method because if we take the limit notation for functions and apply it to this new setting, as the subscripts get bigger and bigger, these x's should be getting closer and closer to the root. Let me write the usually there. It is possible for Newton's method to fail, but I'll show you a successful example of Newton's method in the next video.